Hello everyone, I am Gayatri of Data Science A section. My data structures topic is about quicksort, unexpected speed up in Java multiple processes. Let's take a glance. Now, by upcoming slides, you will get to know more about quicksort and its speed up in Java processes. Introduction to quicksort in Java. The following articles, the quicksort in Java, provides an outline for the quicksort algorithm in Java. The quicksort algorithm is one of the sorting algorithm which is efficient and similar to of merge sort algorithm. This is one of the preferentially used algorithm for real-time sorting purpose. The worst case time complexity of this algorithm is 0 n to the power of 2. The average case time complexity is 0 of n log n, and the best case time complexity is 0 and n log n. The space concept complexity is if 0 n log n, where is n is the size of the input. The process of sorting involves the paginating of input and recursive iterations and making a pivotal element for each recursion. The type of sorting in this algorithm involves the comparison of adjustment elements in the iterative manner. Look at this quick sort method in the given picture below. How quicksort work in Java? Quicksort algorithm can be implemented in Java by following the pseudocode with the sequence of steps designed and followed. The main principle of quicksort algorithm that it works is based on the divide and conquer the approach, and it is also an efficient sorting algorithm. The input array is divided into sub-array, and the division is based on the priority element, which is the central element. The sub-array on the either side of the pivotal element are the main areas where the sorting actually occurs. The central pivotal element is the base to the divide the array into two portions where the left half of array elements are lesser than the pivot element and the right half of array element are greater than the pivot element. Before considering the pivotal element, it can be anyone from the element of an array. This is normally considered the middle one of the last one or the last one for easy of understanding. The pivotal element can be a random one from any of the array. In our example, last element of an array is considered as a pivotal element. There the partialization of the subarray starts from the right end of the array. Finally, the repetitive element will be in its actual sorted position after the completion of sorting process, where the main processor of sorting lies in the partial logic of sorting algorithm. The efficiency of the algorithm depends on the size of the subarray and how they are balanced. The more the subarray are unbalanced, the more the time complexity will be, leading to the worst case complexity. The selection of primitive element in a random manner results in the best complexity in many cases. Instead of choosing a particular start, end, or middle indexes as their pivotal element. Examples to implement the quicksort in Java. The quicksort algorithm has been implemented using Java programming language as below. The output code has been displayed under the code. The code initially takes the input using the final quicksort alg brackets open close with the array, the initial index and final index length of the array as the argument. After calling the quicksort algorithm method, it checks if the initial index is less than the final index and then calls the array partial method to give a primitive element. The precision element contains a logic of arranging the smaller large elements based on the element values of a pivot element. After getting the pivot element index, after the partial method execution, the quick sort method is called itself the recursive until the subarrays are partially sorted complete. In the partial logic, the last element is this last element is assigned as a parity element and the first element is combined with the parity element. The last one where the elements are swapped based on whether they are smaller or greater. This process of recursion happens until all the elements of an array are partial and sorted, where the final result is combined sorted array. Implementation of quicksort algorithm in data. Here is an example of quicksort algorithm in Java. Let's look at this example and get the output of quick sorting algorithm. Quick sorting algorithm in Java. Quick sort in Java, also known as partial exchange sort is a divide and convolution sorting algorithm. Quicksort is a good example of an algorithm that uses CPU caches because it is divided as convolutional nature. Quicksort algorithm is one of the most used sorting algorithms, especially to sort large lists, and most of the programming languages have implemented it. The quicksort algorithm divides the original data into two individual sorted and then merge it to produce the sorted data. Let us consider the array 863492217 needs to be sorted quickly using quicksort. Steps to implement the quicksort algorithm. Choose an element called pivot from the array. Generally, the middle element is chosen as pivot. Let us take 4 as a pivot. Rearrange the array into two parts such that the elements less than the pivot become before the pivot and the elements greater than the pivot appears after the pivot. The following steps are followed. Pick the left element, that is, since 4 is a pivot and the 8 is more than 4 and 8 needs to be moved to the right of 4 on the right hand side, and we leave 7 since it is greater than 4, and pick 1 for swapping with 8. Hence, after swapping, the array becomes 1634928. Pick the left element, that is 4, since 4 is a pivot and 6 is more than 4. 6 needs to be moved to the right of 4 on the right hand side. We have 7, 8 since they are greater than 4, and pick 2 for swapping with 6. Hence, after swapping, the array becomes 1 2 3 4 9 9 6 8 7. Pick the left element, that is 6, since 4 is a pivot and 6 is more than 4. 6 needs to be moved to the right of 4. On the other hand, we have 7 8 7 8 since they are greater than 4, and pick 2 for swapping with 6. Hence, after swapping, the array becomes 1 2 3 4 9 6 8 7. Now, since all the elements to the left of the pivot are less than the pivot, all the elements to the right of the pivot are greater than the pivot. We are done with 4 as a pivot. Recursively apply step 1 and step 2 for the left sub array and right array with the elements less than the pivot, and for the right sub array with the less with more than the pivot. If the array contains only 1 or 0 elements, then the array is considered as assorted. Here, the programming implemented quick sorting algorithm. See these steps and syntax clearly to get a brief explanation about them. This is a program code which look at it carefully because it's a swapping and the quick sorting and swapping algorithm is, and here is output and advantages of quick sorting algorithm. Following are the advantages of quick sorting algorithm. Excellent locality of reference. The locality of reference is ability of processor of access the same memory location repeatedly over a short period of time. Quick sort is in Java provides an excellent locality of reference due to very small number of cache missing, which is on modern architecture is critical for performance. Quicksort is a parallelizable. Once the initial step of partializing an array into small region is completed, all individual subarrays can be sorted independently in parallel. Due to this reason, the quicksort performs complexity analysis of quicksort. Quicksort is a fast and tail recursive algorithm that works by the divide and conquer principle. Here it is a complexity analysis in the best average of worst case. The best case complexity, uh, if an array of a list contains an, ele an elements, then first run will need 0 n. Now sorting the remaining two subarrays takes zeros once. This concludes the complexity of 0 and n log n is the best case complexity. The average case complexity of quicksort is 0, and the worst case complexity is choosing first or last would cause a worst case performance of nearly sorted or nearly reverse sorted data. Quicksort performs 0 of n negation 2 is a worst case. In Java, array sort method uses a quicksort algorithm to sort the array. Here is a step of pivotal elements and sorting technique of quick. Here I conclude by telling that the quicksort algorithm efficient but not much stable as compared to sorting techniques. Efficiency of quicksort algorithms comes down in the case of greater number of repeated elements, which is drawback. The space concept complexity is optimized in the quicksort algorithm. I hope you all have got a brief idea about quicksort unexpected speed up in Java on multiple processors. Thank you.